That's a good sign. Okay, even if it doesn't record, I'll have physical notes for you, right, that I'll post. Okay, today we're going to do numerical integration. It's what you did with Riemann sums, but it's a better approximation. It's sometimes called the trapezoid rule, but more accurate would be a trapezoid approximation. Now, the reason I say that is because the trapezoid rule is specifically when you have even increments. It is a fancy formula, and that is like absolutely useless to you on the AP test because they don't give it even increments. And y'all got tripped up on that on your test. Yes, I'm halfway done with your class. Yeah. So you'll get them back Monday, and y'all have time during the week to work on that. Okay, so what's going on is, what if I give you a function? And I say, want you to approximate the area from A to B. Sound familiar? And I want you to do, suppose I want you to do even intervals. We're going to start with even. So I'm going to say 4 even subintervals. So this is like the problem where I give you a function and I want you to approximate the area. If I give you data, like a table of data, like on your test and like on your worksheets and like the homework, you use all of the, as much of the data, if not all of the data, if you're doing an approximation. And in the trapezoid rule, we use it all. This, if you're given a table, you don't necessarily have even increments, and even if you do, you just use what's in the table. We'll talk about that in a little bit. Okay, if I'm doing 4, am I going to come in here? I'm going to cut this in half. I'm going to cut that in half. I'm going to cut that in half, right? So I have 1, 2, 3, 4 regions, right? And before, if we do it in left hand and right hand, you had to go to the first region and go, that's the left side, that's the right side, and pick the appropriate one, which some of y'all don't know your lefts from right still. We're going to have to work on that. All right, so for the delta x, if you are finding it, hang on, if I am finding it because I have, what, even, only if it's even subintervals, I'll repeat, don't use delta x if you're given data that's not even. Why would you even go find delta x off to the side? You're just going to use the data. We'll get to that. I'll get to that again. But anyway, so even subintervals, my delta x is equal to b minus a over n. Right? Yeah. So that means this point right here is a plus delta x. Do we agree that this is delta x? And this is delta x. And this is delta x. And this is delta x. It's not x, it's delta x for those who labeled theirs wrong. This is a plus 2 delta x's. This is a plus 3 delta x's. And that's b. You'll see what I'm talking about. Well, I need to hear from more than just one. Yeah? Affirmative? It's making sense? Okay, good. If we see it, yeah, enough times. All right. So this time, instead of a rectangle, we're going to make trapezoids. Trapezoids. So I need a different color. I want something really bright. This is what I'm going to use now. Oh, wait. I need it really thick, too. Okay, because y'all are being thick. Dense. If I connect up, from this function point to that function, so this up here, this is f of a. Oh, that's not going to work real well. Hang on. That's too thick. This is f of a. This is f plus delta x. F of a plus delta x, right? Do you agree? We take this x, we plug it in the function, and I'm going to connect up those two. Did I make a trapezoid? Here, let me help you. Did I make a trapezoid? Oh. Now watch. Watch. So this height this height, that's the base, and this is the other base. So for the next one, is this the bottom and this is the top base? Bless you, allergic trapezoids. For the third trapezoid, is this the bottom base and this is the top base? And for my last one, this is the bottom, and f of b is my top base. And if I'm connecting up from the points, I've got straight lines. Is this a much better approximation? Yeah, it's a better approximation. It's just more of a pain to do the calculations. But in reality, right now you're learning to do it by hand. Would you put this in a computer if you had to do it? If is when. Yeah. If. More importantly, these are really simple numeric approximations. Are you going to use this concept and do more complicated approximations for things that you can't actually integrate? Yes. We're just trying to come up with ways to approximate when we have something that's just funky weird. And guess what? In the real world, things are not linear. We like to make them linear. If you really want to make things linear, do log-log scale. It takes almost any weird data and makes it more linear. Trust me, I baffled my peers in graduate school with that all the time. Geologists aren't, I shouldn't say that. Geologists aren't real good at math all the time. Unless they're geophysicists. The geophysicists are brilliant. The rock jocks, not so much. Here we go. You ready? Here we go. So do you remember the area of a trapezoid? Do you remember anything from geometry? Area of a trapezoid is equal to, the area is equal to base 1 plus base 2 over 2 times the height of your, right? So we'll just say h. H. In our case, base 1 is f of the first one, so f of a. And then, so if we're doing this, and then this, we got f of a plus delta x, right? Those are our bases. Over 2 times the height is at delta x every single time. Oh my. So could we write a trapezoid formula for each of the areas? And I will tell you on the AP test, that's what they expect. They don't want you to memorize. There's a rule that if these are all x's, can you imagine if all the delta x's are the same and they're all divided by 2, I could factor out delta x over 2, and then just have the function values added? I could. But they don't want to see that on the AP test, so they purposely give you uneven increments so that if you use that formula, you will get it wrong. So write out each trapezoid. So we actually did the first one. That's the first trapezoid. That is the formula for the first trapezoid. Now watch. Now I'm going to do the area by trapezoid for the region 2. So for this one, is it f of a plus delta x plus f of a plus 2 delta x's over 2 times delta x. Notice that I'm using that again, aren't I? Because look up here, did I say that it was the top of the first one and bottom of the second one? The next one is the top of the second, bottom of the third one. Do you see how they're used twice if they're in the inside and the A and B are only used once? When you get to college, if they let you use the fancy formula, they'll say delta x over 2 times f of a plus 2 of the next one plus 2 of the next one plus 2 of the next one plus 1 of the last one. But AP test doesn't want that, so we're just going to learn to do trapezoids. Can you do trapezoids? Okay, so for area 3, is it going to be f of a plus 2 delta x's plus f of a plus 3 delta x's all over 2 times delta x? And for our last one, what's it going to equal? Huh? Say it clearly. F of 3 delta x's plus f of what? What's the last one? F of b all over 2 times delta x. You could say f of a plus 4 delta x's, but why would you when you know what b is? Capiche? Notice that each time I use the interior ones twice. I use that one twice. I use this one twice. So when you're going through and doing this, that should be you're starting at A. You add the next one. You use that one again. You add the next one. You use that one again. You add the next one. You use that one again, and then you get to B, the outer boundary. You stop. When you're at the bound, you start at A, and when you get to f of B, you stop. It's that simple. And is the total area, is my total area equal to the area 1 plus area 2 plus area 3 plus area 4. And if you will write that out and plug in the numbers, if it's non-calculator, even if you don't evaluate it, that will give you full credit on that part for the AP test. That will get you full credit on my test. Oh my. That wasn't too bad. Okay, let's do an example, because that's it. That's the trapezoid rule. Let me draw one more thing for you. So off to the side, I'm going to draw this trapezoid. So here's the trapezoid I did. So my first one, is this the trapezoid? And labeling it is this delta x. Whichever one it is, right? And is this, so this one, this height right here is, if we're supposing this is A and this is A plus delta x. This is f of A, and this is f of A plus delta x. That's base 2. This is base 1, and this delta x is the height. So it's base 1 plus base 2 divided by 2 times height. Did you know trapezoids are just rectangles?
Yes.
Yeah? So is that why it's divided by 2? What you're doing is you're averaging these two. Turn it sideways. If I'm averaging the two heights, will I get the height of the rectangle that has the same area? And then it's time isn't rectangle would be the base times the height, but I gotta have an average base, so it's somewhere between, right? The way to remember this is draw an isosceles trapezoid down here. You know how the isosceles trapezoids work? Like so, right? If you chop this triangle off and you flip it over here, does it make, you'll see that I'm making a rectangle that is the average of the two bases and is the height? Is that where that formula comes from? Oh, y'all didn't learn anything in geometry, did y'all? Okay. I like teaching geometry. It's so much fun to mess with freshmen. All right, so let's try one. Example 1. Yeah, it was easy. Approximate. Mrs. White's geometry was not as easy, because Mrs. White challenged the smart little boogers. And you know what was funny? When I taught Geometry K, I was also teaching AB Calculus. And so I would take AB Calculus questions and turn them into geometry questions. Imagine volume and area, right? And ladder problems. All those related rate problems y'all did, my geometry kids did too. And then I took their problems and turned them into calculus problems. Some of the calculus problems you do are actually Geometry K problems. And I just moved everything. And I told them they were doing each other's problems. And I had siblings that were both in both classes, freshman and senior. It was kind of fun. I pitted them against each other. Okay, I want to approximate the area under f of x. I will extort and point y'all at each other and whatever it takes to get y'all to, oh, I can't write and talk. I can't do story time and talk. Y'all can't either. I mean, in math. All right, here we go. Whew. We're going to approximate the area under that curve over the interval from 0 to 2. Use a trapezoid approximation with 4 even subintervals. So we're going to start out, when we're doing it from scratch, we're going to do even subintervals. And then eventually I'm going to give you data, because in the real world what happens when you're doing this, you're given data and it's not even, because whoever was doing the timing for collecting their data did not get it right on every minute. Having taken data in the real world when I was an engineer and when I was a scientist, getting your data collected on if you don't have automatic sensing, which generally, if the problem is, if you had automatic sensing, you would have enough data and this wouldn't be an issue. But generally, if somebody's doing it by hand, your time intervals are not even in the real world if somebody's collecting data for you. You have to use what you're given. So first, we're going to pretend that we can do this, right? All right, so first off, just like on the rectangles, do we have to find delta x? So in the problems, when I give you the function and I say do it with even, do you have to find the delta x? Yes. What is delta x equal to? What's my a? My a is 0, my b is 2. So is it going to be 2 minus 0 over how many subintervals? 4, and they're even. That's why I can do this. I'm doing this because they're even, right? I want delta x when they're even. I don't want it when they're not even. Is that 1/2? Yeah? I can sketch this, but I'm not going to. All I want is the bottom. Just like on the rectangles, when I say sketch it, you don't have to sketch the whole thing. All I need is the bottom. You literally just have to go like this. And I'm starting at 0 and going from 2. Whenever you're doing this, you should look at the interval, because if it's not starting at 0, why would you? Somebody else did that. You're supposed to be starting at 2 and you started at 0. That pretty much makes all your numbers useless. I'm going to do 4 subintervals and steps of a half. That's 1, that's 1/2, that's 3/2. That was easy. So this is the first trapezoid, this is the second, this is the third, and this is the fourth. So I've got some sort of trapezoid thing going. It doesn't even matter what it looks like. You don't have to actually draw a graph. All you have to do is draw the bottom. Can you figure it all out from the bottom? Yes? Yeah. Okay. So from this, if my function is equal to x to the 2/3 power plus 1, can I go find each one of these areas? For the first area, it is the first base, which is f of 0, plus f of 1/2 over 2 times, what was my delta x? 1/2. Plus, okay, I'm going to do it. I'm doing them separately. 2. Well, can we plug those values in? For this one, I actually like to write these because I don't want to mess up. It's a lot of detail. So I write it out, and then, okay, now I'm going to plug that in. So for the first one, when I plug in 0, it's just 1. So it's 1 plus, and then I'm going to plug in a half. So I have 1/2 to the 2/3 power plus 1, and it's a half of a half. Is it just over a fourth? You can write out 2.5 and not evaluate it, but is it really just a fourth? Yes. Okay, for the next one, am I going to do the f of 1/2 plus f of 1 all over 2 times 1/2? If you write this out, is it really easy to write out? I'll show you how easy. I actually, when I do this, I really do it because y'all, I can't do homework without getting distracted, so nobody will leave me alone. There we go. Over 2 times 1/2. And then for my final one, do I use this again? And is it going to be f of 3/2 plus f of 2 all over 2 times 1/2? Was that easy? And then just plug it in. For this one, it's going to be the 1/2 to the 2/3 power plus 1 plus, put 1 to that power, is it just going to be 2 over 4? For this one, I used the 1 again, which was 2, because it's 1 to the 2/3 power, which is 1 plus 1 is 2, plus 3/2 power to the 2/3 power, 3/2 to the 2/3 power plus 1 over 4. And for the last one, I have the 3/2 to the 2/3 power plus 1 plus, if I do 2 to the 3/2 power, oops, 2/3 power. I'm being dyslexic. There we go, plus 1. You know, everybody has those moments, right? I do better when I don't have to talk. It's kind of difficult when you teach, though. That wasn't hard, was it? Can you all plug into a function? I don't ask you to evaluate it without a calculator. If I ask you to give me the actual value, will I give you a calculator and you just have to punch it in correctly? Any questions? If you want the total area at the bottom, to get full credit on the AP test, you have to go A total is equal to the first area plus the second area plus the third area plus the fourth area. And what they will do, if they give this on the non-calculator, the numbers will be really easy. If they give it on the calculator, you just have to add those all up and round them to the, how many decimals? How many decimals am I telling y'all?
2.
No.
3.
Oh, Lord. 3 decimals. Unless noted otherwise, you want 3 decimals. And if you look at the grading, when I've either on the grading guide they tell you, or it's in the classes I take, they take the, so that's 100th. So it's up 1 and down 1. So as long as you're within 1/100th of the actual answer, they will give it to you. It's truncating error, so they just, the rounding or truncating, they give you the 100th. Okay, can y'all do that? Yeah. So is that one kind of problem? What's the other kind? And we did this with Riemann sums and it was on your test. This is the other kind of problem. Example 2. What if I give you data and somebody wasn't paying attention and the times, they are not constant. So now we're going to approximate, oh, hang on, I can't write. Approximate displacement, so it's particle motion, and we'll get to this in chapter 6. We've already talked about it a little bit, 0 to 3.5 seconds for the following velocity data. And you hope it's something this straightforward, because it never is. On the AP test, they will give you data, and they will make you do some sort of approximation. It could be Riemann sum, it could be trapezoid. All right, so my data is I have time in seconds, and I have velocity in feet per second. It could be meter per second, but in this case it's just... So somebody took some data at 0.5, and 1, and 2, and 3, and 3.5. Notice the delta x's are not constant. They did not say go from this value to this value on even increments, and I want 4 of them. So you don't go find delta x overall. You find each delta x. And then the data they gave me is 44, 44, 37, 22, 7, and 0. What I need you to all realize that this is my first trapezoid. This is the first trapezoid. This is base 1, this is base 2, and this is the delta x. What is my delta x? 1/2 equals the delta x for the first one. Am I going to do that for each one? So what I'm going to do, actually, I want to, oh no, I didn't, no. I want to shift this down so that I can actually have room to scribble on this table. There we go. Okay, so 1/2, that's the delta x for that one. So my second one, this is my second this one right here, is that the second one? Yeah. For that one, what's the delta x this time? Delta x2 is equal to 1/2. What's delta x3? 1. What's delta x4? What's delta x5? And I don't write the delta x's, I'm writing that for your benefit, but I would literally go, this is a half, that's 1, that's 1, that's a half. Base 1, base 2, base 1, base 2, base 1, base 2, base 2, repeat, repeat, rinse, wash, right? Yeah. So let's write this out. So for my first area, what's my first base? 44. What's my second base? 44 all over 2 times what was my delta x? 1/2. Plus, oops, no, we're going to do each one separately. Second area. Is it 44, which is the second one, plus 37 over 2 times what was its delta x? 1/2. Oh, is it starting to click now? The third area. Is it going to be 37 plus 22 over 2 times what was it delta x? 1. And my fourth area, because there's 5. Do you see that there's 1, 2, 3, 4, 5 trapezoids? So it's 22 plus what? 7 over 2. What's its delta x? 1. And my last one is 7 plus 0 over 2 times 1/2 is my last delta x. Wow. Notice, when you were doing this, did you use the same one twice in the middle? And then the one at A and the one at B were only used once. Do y'all see that? Yes? That wasn't bad, was it? No. And you didn't even have, you don't even, for this one, you don't even have to do anything. You're done. If I don't give you a calculator, if I give you a calculator, can you find that this is going to equal my total? If I have area total is going to be 88 feet. It's approximately. Because they wanted, this one, I didn't round to 3 decimals, I don't think. I can't remember if I rounded to 3 decimals or not. But what does this equal? What integral is this approximating? It is approximating the integral from 0 to 3.5. Is that my time? Am I integrating velocity? dt. And do we know that the integral of velocity is position? And if I don't put any absolute values around it, it's displacement. If I want total distance, do I need absolute values? We've talked about this before. Yes. And that, y'all just need to start. Now, the worksheet you have has Riemann sums and trapezoids on it. Because they're all the same kind of thing, right? I just need, and it happens every year. The first time through on Riemann sums made no sense to you. It showed. Now, on this worksheet, hopefully it's going to click now. That if I give you a function in even increments, you go find delta x. If I give you data, just use the data, right? In the table, you find the delta x for each region. If it says do Riemann sum, you tell me left or right, hold up your hand and use that side of each region and find the area of a rectangle. If they say use trapezoids, find the area of each trapezoid, which means you're going to use both left and right side. Yes, you should try this. Let's see if it worked.